Hi, we're going to talk about Lab 6, which is the lab for our programmatic thought lesson. So in Lab 6, you are going to get to actually write a program yourself. So this is going to be your first individual hands-on programming lab, which is going to be fun. So you're going to get to work more with Google Colab and use it to solve some real engineering programs. You're going to be using Python again. And what you're going to do is choose an appropriate engineering problem, design an algorithm to solve it, and then create the code to bring it to life. And when you do that, don't forget to use appropriate comments so that the other people will understand what your code is doing, and also to test your code using standard values as well as edge cases. So remember, edge cases are unusual values, things like numbers with decimal places, negative numbers, zeros, numbers written with characters, and so on. So to do this, you're going to use the Google Colab again. We'll access that the same way you did last time. And we've also got here an example Colab notebook for you, which we'll take a deeper look at in just a minute. So going through the procedures, first you're going to choose an engineering problem to solve. And there are a couple of requirements for your engineering problem. Your problem should first gather some input from the user and then perform one or more calculations on that input and then output the results to the users. And so some examples of engineering problems might include an axial stress calculator, just like we saw in the lecture. You could actually build that calculator yourself. Maybe a speeding calculator. How far over the speed limit was someone driving? Or a calculator to convert degrees Celsius to Fahrenheit, or maybe a calculator to convert kilograms to pounds, or calculate the area of a rectangle based on the length of the sides, or use your imagination. Any sort of thing that's going to perform some sort of calculation, that'll gather input, perform some sort of calculation, and then generate output. Even better if it's something that would be useful to you in your engineering studies. Okay, so to do this, you first are going to access Google Colab. And so to do that, go to the Colab site, sign in with your Google account, and click on File, New Notebook. So let's go to the site, and I think I'm already signed in, so it's probably going to just go straight there for me, indeed. So it might ask you to sign in, and you can just use your PCC account for that. Now, if it comes up like this for you, you can just click New Notebook here in the bottom corner, and it'll open up a new notebook for you. If it doesn't come up exactly like that, you could go to File and New Notebook in Drive, and that would open up a new notebook for you as well. Now, when the new notebook opens, you're probably going to want to name it something that helps you identify what it is. You can see this one right now is called Untitled 3, which is, not a very informative name. So let's name it something better. Let's call it Lab 6, or let me see, we actually suggested something, I think here. Yeah, Lab 6 Programmatic Thought. So let's call it that. Lab 6 _ programmatic thought, .ipynb, and you want to keep that .ipynb at the end so that we know that it's a Google Colab file. Okay. So once you have that, then we can start doing interesting things. So if you hover your cursor over this area right here between this box that has the arrow in it and this area with the plus code, plus text, plus run all, you'll see it has a plus code and a plus text. So if I click one of these boxes, it will add a new area for me. So if I want to add text, for example, I would click plus text. And then I can use that to follow the next procedure in the lab, which, as you can see, is add a text cell for documentation, right? So it says here, click on the plus text at the top of the Colab interface. And then in this text cell, write your name, the date, and a brief description of what this lab is going to do. So you just double click to edit here. I would write my name. Today is the 10th of September. And we're going to write a brief description of Lab 6 and what it's going to do. And you, of course, would fill in more details than that. Okay, and so then let's go back to the procedure. Okay, so your next step, well, and make sure to include in that text cell, the problem that you're actually going to tackle with this algorithm. So for example, the program will calculate the area of the rectangle based on user input or whatever the problem that your program is going to solve. So now you want to actually write your Python code. So if you don't actually see a code cell there already, you're going to click on plus code to add a new code cell. And then you're going to write a program that does the following. Ask the user for input using the input function, then calculate a solution to that engineering problem you chose using mathematical functions. And I gave you a couple of examples here. For example, multiplication uses this format A asterisk B in Python. Division uses this format A/B. Or if you want to raise something to the power, like if you wanted to say A squared, you would say A, the little hat symbol, and then 2, that would square A. And then outputs the result and a meaningful message using the print function. Okay, so let's jump back to our lab here. So this block right here is a coding block. So I can do a couple things. First of all, if I wanted to include some comments here, like maybe I want to say what this code is going to do, let's say that I wanted to include, let's see, I wanted to say, first thing I'm going to do is gather input from the user. I could put a comment, and you can see this little asterisk is telling me that it's a comment, and then I could start actually writing the code. Now, you remember I said back in the lab, we actually have an example of an engineering problem for you. So let's jump over and take a look at that. Oops, I don't know why that jumped, but let's come back. Okay, let's take a look at this example engineering problem. So if I click on that link, that will take me to another Google Colab file. And this is actually an example code to solve an engineering problem. And so you can see here, we have a number of comments at the top to lay out what this is. Example code to solve an engineering program, says who it's created by and when, later modified again, and what this does. This is a wind chill calculator. So it's going to get input from the user of the temperature in degrees Fahrenheit and the wind speed in miles per hour. And then it's going to calculate the wind chill per the National Weather Services formula, where wind chill is equal to, in degrees Fahrenheit is equal to this formula right here. And then it will output the wind chill. Okay, so in doing that, step 1 is going to be to ask the user for input and store it in a variable. And then the input function displays a message and waits for the user to type something. Whatever the user types is stored as a string in the variable. It asks for the user input and then checks to be sure we got a valid wind speed. And then casts the input to an int so we compare it to 0. Okay, so it kind of explains what these first steps are. And so then you can see here's the actual code that does that. So this variable temp, we take the function input, it's going to ask the user what's the temperature in degrees Fahrenheit, wait for their answer, and then store that response in the variable temp. Then the next thing we're going to do is we're going to ask the user for what's the wind speed in miles per hour using that input function again. And we're going to store it in the variable wind. And this time I want to check if I get a valid response from the user. So I'm actually going to compare the response to the value 0. So I say here, while wind is less than 0, keep asking the user what is the wind speed in miles per hour. And what that's doing is it's saying if the user is giving me a negative number, that's not right. That's not a valid answer for wind speed. So keep asking them for a wind speed until they give me a valid answer. Okay, then once I get a valid answer, we calculate the wind chill. So another comment that says what we're doing, and then we plug in the formula to get the wind chill. And then we're going to output the wind chill. And I'd like it to look nice, so we're going to format it to print only 2 decimal places. So we have our print statement and this bit with the F, and then here where it's got the colon dot 2F. What that's doing is telling it to have only 2 decimal places. It's going to say the wind chill is whatever we calculated in degrees Fahrenheit. And then we wanted to have a little bit of fun with it. So we print some fun messages just based on how cold the wind chill is. We do some comparisons. If the wind chill is less than 0, print this message. Else if the wind chill is less than 20, a different message, etc. So let's try running this code and actually seeing what happens. So in a Colab, if you recall, when you hit this arrow, it executes the code that's in this code box. And the first time you run it in a Colab, it always takes a minute. It's just, give it a minute. It'll be faster after the first time, but the first time always takes a minute. So that's okay. So it's ready now. So you can see it shows the output of the running the code in this window right below the code box. So right now it's running this first part of the code. So remember, the first thing we did is we have this input function that's saying what's the temperature in degrees Fahrenheit. So it's waiting for me to respond to that question. So let's say the temperature is 25 degrees. So I hit return. And then it says, what's the wind speed in miles per hour? So let's say I put -10. Okay, so remember we said that this is checking to be sure that my answer is valid, and it sees that it's a negative number, so it's not a valid answer. So it asks me again. So, okay, now I'll say 5. That's a valid answer. So it goes on, it calculates the wind chill, and then based on this wind chill, it chooses one of these messages and prints it out. And that's the whole program. Okay, so coming back to the lab, so you're going to use that as an example, and you're going to use that to come up with your own engineering problem that you want to solve, and you're going to actually write your program, run it, observe the output, and then test your program. So I want you to really think about how to thoroughly test your program. Try various different inputs. Look at what happens if you input a number with a decimal point or a negative number or 0, or what about if somebody wrote the number 4 as FOUR instead of typing it as a number. Are there any improvements that you can make to your code? I showed you one way to handle an error there, but there are others. You might Google simple error handling in Python, for example. And then make sure that you save your work to a place that you know where it is. Colab is automatically going to be saving your work to your Google Drive, but you might want to just make sure you know where it's going. So you might come to File, and you could say save a copy in your drive, or come down to Save, and then make sure that you save it someplace that you know where it is, perhaps in a lab folder inside your Engineering 101 folder overall. Okay. Okay, and then for a successful lab report. Okay, so once you've completed the notebook, like I said, ensure that it's saved. Make sure all the code blocks are visible. So if I come back here for a code block, you can, when you click on these things, somehow you can end up collapsing them. I forget exactly how you do it, but somehow these guys can get collapsed like this. Like here, I can hide or show things. So you want to make sure everything is being shown so that all the code is visible, all the output is visible. Make sure all the code runs without errors. Like, let's go back. If let's suppose that I had forgotten to put this colon right here so that colon's not there, and then I try to run it. Okay, so you can see right here it's come back and said syntax error, it expected a colon. So that's the type of error you would see if there's something wrong with your code. Make sure that you go through and fix all of those issues and that everything is running in your code before you turn it in. And make sure that you go through and execute fully the program so that we can see that it's executed. Okay, and then what you're going to do is actually print the Google Colab as a PDF. And so before you do that, make sure the theme is set to light. And the way that you do that is you go to Settings, and then Site, and then Theme. Okay, so let's do that. So Settings is this little wheel up here. So you click Settings, and it comes up, and usually it's already on Site and Theme. Okay, and so you can see theme has light, dark, or adaptive. And so make sure it's set to this light and click Save. And then you're going to actually print your file as a PDF. So to do that, what you do is you come here to File and say Print, which sometimes is below the fold of the screen. So say Print, and then on Destination, choose Save as PDF. You know, sometimes it'll come up and it'll automatically be your printer. All you do is you select on it and say Save as PDF. And so that's going to choose a file. You'll save it, and typically that's going to put it, typically it'll put it in your download file, but it might put it somewhere else. Just make sure that you check where this shows you the folder where it's saving it, and this is the file name, and you can change those when this window comes up, but just choose where you want it to go, and then you say save, and that'll give you a PDF file. So once you have that PDF file, then you can see it in your folder. So if I look at my download folder, I now have this example code. I now have example code for that file that we just saved. Open that up and then check the formatting. And if there's any formatting errors, correct them, and then reprint your PDF file if need be. And then you can upload that file to the corresponding assignment folder. Just keep in mind, if you upload multiple times, only that last submission will be kept. All right, with that, have fun with the lab.